Welcome back to Chapter 3, Structure and Bonding, Section 3.5, Covalent Bonding. By the end of this tutorial, you will be able to explain how covalent bonds are formed and describe how covalent bonds are represented. We will begin by discussing covalent bonding. When does the covalent bonding occur exactly? We have already seen that the reactions between metals and nonmetals, they usually result in compounds with ionic bonding. We observed that in the previous videos. However, many more compounds, including the vast majority of those making up your body, are formed in a very different way. When nonmetals react together, their atoms share pairs of electrons to form molecules. And this is called covalent bonding, when atoms share pairs of electrons. So, in general, covalent bonding and the electrons inside them, they are being shared. Now, let's discuss simple molecules. The atoms of nonmetals generally tend to gain electrons to achieve stable electron structures. So when nonmetals react together, neither atom can give away electrons. So they get the electronic structure of a noble gas. How? By sharing electrons. So nonmetals, when they react together, they achieve stability by sharing electrons. And the atoms in the molecules are then held together by the shared pairs of electrons. These strong bonds between the atoms that was formed by the shared electrons are what we call covalent bonds. So, whenever two atoms like these, they are holding each other's electrons and sharing them, they are forming what we call a covalent bond. Now, let's observe together some simple molecules. And let's begin first by the hydrogen atoms. If we have the hydrogen atoms which are alone, one hydrogen here and the other here, we know that each hydrogen atom carries only one electron on its outermost shell, which is the only shell. If the two hydrogen atoms, they react together and they share the electrons, we will form what we call the hydrogen molecule, which is the H2 gas molecule that we have in the air. According to the following structure, we represent a shared pair of electrons, which gives both atoms a stable arrangement and forms a covalent bond. So these two electrons, the cross shape and the dot shape, they form a covalent bond between the two hydrogen atoms. And now it's stable because the hydrogen, it only needs one more electron to become stable. Let's take another example here, which is the oxygen atom. If we have two oxygen atoms, we know that the oxygen have 6 electrons on its outermost shell. So it only needs 2 more electrons in order to become stable. If we have two oxygen atoms that react together, they will share their electrons. And in this case, if you observe here, we have 2 double bonds. We have 2 covalent bonds. If we have 2 covalent bonds, it means we have a double bond. So we have 2 pairs of electrons involved, and only the electrons in the highest energy level are shown here. So we have a dot and cross and another dot and cross. This means we have 2 pairs of electrons involved. And another example, which is if you have 2 nitrogen atoms, the nitrogen have 5 electrons in its outermost shell, so it needs 3 more electrons in order to become stable. So what happens here, the 2 nitrogen atoms, they share 3 pairs of electrons in order to become stable. And these 3 pairs of electrons represent a 3 covalent bonds, which we call triple covalent bond, as you can observe here. If we look at the following example, which is HCl, Hydrogen needs one more electron to become stable, and chlorine the same. So they share the one pair of electron and they become hydrogen chloride stable. If we look at the water molecule here, it represents the example that we mean by not having the same number of electrons to be shared. So the oxygen atom here needs two more electrons in order to become stable. However, the hydrogen atom, it needs one more electron. So if we are going to allow only one hydrogen to react with oxygen, they won't form a stable atom. That's why we need two hydrogens to react with one oxygen. And after we do that, we will get the water molecule H2O, which is the stable molecule, because by now each hydrogen shared a pair of electrons with the oxygen, and now we got a stable atom. Another example is the methane, which is CH4. Carbon has only 4 electrons in its outermost shell, so it needs 4 more electrons in order to become stable. And the best way is to react with 4 hydrogens. As you can observe here, carbon shares 4 electrons with 4 hydrogen atoms, and this is how we get the stable methane molecule.